So let's give this a try. So can we show that this quadrilateral is a parallelogram? We have basically what I'm looking at here is the lengths of the diagonals, and I immediately can say no for this one because a parallelogram, by definition, if you look at your chart, says that we have we bisect our diagonals with the other diagonals. So this is no, that's not bisecting. Can I show that this quadrilateral is a parallelogram? All right, so for this one, pretty sure it's also going to be a no, just because 7 and 8 don't add up to 0. And what I need is for consecutive angles like these to add up to 180 degrees. So this would actually be fairly close, but it's not going to add up to exactly 180. All right, let's look at this. Is this a rhombus? All right, well, certainly looks a lot like a rhombus, but the only thing that I'm given is that it's 97-degree angle right there. Now, this means that it's not going to be a rhombus because my diagonals in a rhombus are perpendicular to each other, so they have 90-degree angles there, not 97. All right, can I show that this is a parallelogram? No, I can't show that that's a parallelogram. Who cares if it has 2 congruent sides? This one, all right, this one actually is a yes, and we have a theorem. You would have to look up which one it is, but we looked at it in the first couple sections. A theorem that says if we have congruent sides, which we do, 48 and 48, and we have parallel that same side, then it is a parallelogram. So this one is a yes. Okay, this one, is it a rhombus? Okay, no, this one says it is a rhombus. So they want to know the measure of angle VXY. VXY. Fun stuff. All right, we're gonna get the iPad going here now. So, yeah, that's not going to cut it. What do we know about rhombi? We know that their diagonals are also angle bisectors, okay? So VXY, we're looking at this angle here. VWXY. And what I anticipate is that we're going to have to take kind of a roundabout approach here because we know that this is 64 degrees, but we don't know that means like this is 64 degrees. We don't know that. But we do know that parallelograms have consecutive angles like this and this that add up to 180. So what I'm going to do is I'm going to do 180 minus 64. And I'm going to do that in my head really fast right now. Or on paper, that works too. So I get 116, yeah, that sounds about right. So this full angle would be 116 degrees. Now, why does that matter when I'm looking at this smaller angle here? This is the one, like we said, that I'm looking at. Finding that itself is not 116. What that is half of 116 because I have an angle bisector that goes through this. So this is congruent to this. So 116 divided by 2, 58, right? Yeah, it's going to be 58. 58, okay. So it should be 58 degrees. Ooh, it's telling me I'm running out of time. All right, let's see how this goes. Cross your fingers. Ah, yes, awesome. Okay, so that was the first 5 minutes, and I'll post another one in a second. Hope you liked this. There's another one coming. All right, bye-bye.